All right. Okay. Right. So we go into truss. So what is truss? Truss are commonly used to support a roof. If you see, we have truss in a roof rumah. So itu adalah truss lah. Alright. So for given truss symmetry, how we can determine the force in the truss member and select their size. So let's say you want to design a roof with a frame or truss like this. So how you need to know the tension or the force in each truss. Okay, so this need truss analysis. Okay, so when you do the truss analysis, you need to know what is the support, reaction, and here and here. If you remember in chapter 4, chapter 4, okay. So in chapter 4, we have learned the support analysis, support system, all right? Support, if you remember, all right? Support reaction. Okay. So please remember, if you have a pin, so the reaction for is X and Y. Okay, reaction for the pin. If reaction for the roller, let's say you have roller, symbol for roller is like this. So for roller, they have only F, Fy. Alright, this is support reaction. Okay, we will use this much in this chapter. Alright, at least you remember these two lah. Alright. Okay, so in chapter 5, we learn the structure analysis. Right, so this is example of a structure that will be used for the application. So we see the pecah warna thread there. Here you see the pecah warna thread, and then you see the chassis of the car. They have a lot of trusses here. All right, so we need to undo analysis so we can analyze which force or which member have greater stress. All right, so this one is for the one or rostrum. All right, so this one is another example. You have a bicycle, they have a lot of truss, lot of structure. This one also, you have a lot of structure. All right, okay. A truss is a structure composed of slender member joined together at their end point. So this is example of truss. All right, joined together consists of member join together at their end point. So this is end point lah, end point, and this also end point. So they join together at one point. All right. So the simplest truss is a planar truss. Planar truss, which begins with rectangular element and can be extended by adding two members and join. For this truss, the number of members M and the number of joint are related by the equation not so clear. So this is M is equals to 2J, I think, minus 3. All right, 2J minus 3. All right. So let's say you have two join. This is how many join? Number of member and the member of join are related by the equation. You have 1, 2, 3. So 2 times 3 minus 3. So you have 3 join. This is 1, 2, and 3 join. Alright, so this is not so important lah. Alright, just your knowledge. Alright. Alright, analysis and design assumption. When designing the both member and joint of the truss, first it's important to determine force in each truss member. This is called the force analysis of a truss. When doing this, two assumptions are made. all loads are applied at the joint. The weight of the truss members is often neglected as the weight is usually small as compared to the force support by the members. Alright, so that means all loads are applied at the joint. Alright, and the weight of truss member are neglected. You can neglect the weight of the member. Alright, the member are joined together with smooth pin. Alright, so let's say you have several truss. Right, I draw a simple truss here, like this. Alright, so all loads are applied at joint. So semua load kat joint. Let's say you have F1, F2, right? You have F3. Okay, all loads are at joint. And then the weight of the truss are neglected. So weight of the truss kita boleh abaikan lah. Weight ni kita boleh abaikan. Alright. The members are joined together by a smooth pin. So kat sini kita ada smooth pin. Pin simbol dia macam ni lah. Alright. Alright. This assumption is satisfied in most particular case where the joint are formed by bolting or welding. Alright. Wait. Alright. With these two assumptions, the members act as a two force member. They are loaded in either tension or compression. Right? Alright. So two methods to analyze this truss. One, we have method of joint, and two, second is method of cross section. Alright. So today we'll focus more on the method of joint. Alright. So method of joint. So let's say you have this frame. Okay. Let's say you have this frame. There. Alright, let's say you have this frame. In this method, solving for the force in truss members, the equilibrium. Wait. No. So this is this method of joint. In this method of solving the force in truss member, the equilibrium a joint is considered. Okay, all force acting at the joint are shown in free body diagram. Okay, so this include all external force as well as force acting in the members. So equation of equilibrium, summation of Fx and Fy are 0 are used to solve the unknown force acting on the joint. So let's say this is our truss system lah, right? This is our truss system. Okay, so you have 1, 2, 3, and truss. All right. So the equilibrium of the joint pin is considered. Okay, if you want to draw FBD, we draw FBD at the joint. All right. Let's say this figure, they draw the FBD at joint B. Okay, take the joint B. Let's say this is joint B. Okay. This is joint B. Joint B. Alah, saya tak ada pula. Sekejap Sekejap. Tu tak pergi ya. Alright, let's say this join B. Alright. Okay, you take this B. So we have 500 Newton this way. Alright, the external force, and then each member, this member and this member, they have their own. Okay, so you have force, let's say BA, and force BC. Alright, force BC. So this is for bar BA. Okay, so this is for bar BD, bar BC, right? BC. We don't draw the beam or bar, we just draw the FBD for the joint. Alright, for the joint. Let's say you want to draw FBD for the joint A. Alright, so let's say for joint A, joint A. Okay, so this joint A, you want to draw the free body diagram, you take the point A here. Okay, point A. Point A is pin connected, right? So pin connected, you have AY, you have A, you have AX, and then you have force due to the thrust, FAC, and then you have FBA. Okay, so dekat atas ni you have beam lah. Alright, you don't draw the bar, just draw the arrow, indicated that you have force for the bar. Right, so that's joint A. Alright, so for joint C, let's say this joint C, right? For this joint C, draw FBD for joint C. You have, let's say this joint C. So this is rocker. Remember from the chapter 4, this is rocker support. So rocker support only have one unknowns, C, let's say CY, right? And then you have force due to bar. Okay, force due to bar. This is FBC, and then this is FAC, alright? So basically you have a bar lah here, right? Bar here. Right. So the direction of the force, it doesn't matter. Okay, you can assume, is it this way or that way? You can assume for yourself. If you get negative answer, so the answer is opposite direction lah. Right. Always start analysis on joint with maximum 2 unknowns. Alright. So let's say so this one we have 4 unknowns: FTC, FCD, FCY. We have 3 unknowns. Alright, we have 3 unknowns. So you cannot start with this joint. Okay. For joint A, you have 1, 2, 3, 4 unknowns. You have 4 unknowns. Alright. For joint B, you have 2 unknowns. You have FBA and you have FBC. You have 2 unknowns. So you start with 2 unknowns first. Why? Because you only have 2 equations, which is summation of fx is equals to 0 and summation of fy is equals to 0. So 2 equations, you can only deal with max 2 unknowns. Alright. Ada moment tak? Ada moment sebab for thrust support, you only deals with two equation because we deal with the joint particle. So particle considered no moment lah, right? At the joint, right? So method number two, if you remember, so method number two, this one we can use up to 3 unknowns. Alright, this one I will delete lah. This one only 2 unknowns. Alright, because they have summation of fx0 and summation of fy0 for this one. For method of cross section, you have one more, which is summation of moment is equals to 0. And then summation of fx and fy is 0. So with this, today we concentrate with this method of join first. Alright. Alright. Step 4 analysis. We have 4 steps. Number 1, draw FBD and determine the support reaction. Support reaction means reaction at AX, AY, okay, reaction at CY, so reaction at support. Okay, so that's number 1. Draw FBD and determine support reaction. Number 2, draw FBD of a joint. Okay, draw FBD for the joint. Yang ni draw FBD for the global, for the global picture, global diagram, global figure. Alright. And then number 3, apply scalar equation, which is summation of fx and summation of fy is equals to 0. Before I forget, trick to identify tension or compression. If pull to the joint is tension, if push to the joint is compression, like this one. Okay, like this one. This one is pull from the joint. Okay, you tarik joint tu, ini joint lah. You tarik joint tu, ini tension. Alright, tension. Yang ini pull to the joint, tarik joint tu is tension. Tak ada contoh lah. Contoh yang ni lah. Yang ni tarik joint, pull joint, tension is tension. Alright. So yang ini push to the joint, dia push ke dalam. Push, that mean is compression lah. Alright. So that's trick lah. How you identify is it tension or compression. Right. So direction you can assume first, and if you get the difference sign or negative sign, that means this opposite direction lah. Alright. So repeat step 2 and 3 for each joint until all force are determined. Alright. Alright. Example, problem number 1. Okay. Problem 1. So determine the force in each member of the class and indicate whether the member are in tension or compression. Okay, so remember your step. So step number 1, you have determine reaction at support. At support. Right, so determine reaction at support. So macam mana, how you want to determine reaction at support? You can draw FPD for the whole picture lah. Right, like this one, you have thrust like this. Alright, and then you have this one is pin, this one is rocker. Okay, this one is rocker. So for pin you have A, Y, and you have A, X. For rocker you have only one unknown, C Cy. And then you have external force, which is 500 Newton, right? 500 Newton. This is point B, and this point C, right? Okay. So determine reaction at support. So macam mana nak determine? You can use equation of equilibrium, which is for the reaction at support, you can use 3 unknowns. Okay, only for joint, you need only use three equations. So you can use summation of M A is equals to 0. So you have 500 times 2, which is minus, is clockwise, and then plus Cy times 2, right, is equals to 0. So this is how you determine the Cy. So Cy is equals to, take your calculator. I have my calculator here. So 500 times 2 divided by 2, you have 500 Newton. 500 Newton for Cy. Alright. So here the same, the positive, this means the direction is true. 500 Newton. Right. And then take the summation of, let's say, Fx is equals to 0. Right. Take the summation of Fx is equal to 0. You have 500 plus Ax is equals to 0. So you have Ax is equals to minus 500 Newton. So your correct direction is here lah, Ax equals to 500, right? Okay. And then summation of Fy is equals to 0, right? So you have Ay plus Cy is equals to 0. So Ay is plus 500 equals to 0. So Ay is equals to minus 500 Newton. Right? So your Ay also this way. Ay is equals to 500 Newton. Right? Okay. So that's step number 1 lah. Alright? Step number 1. So step number 2. Step number 2, you need to step number 2, draw FBD for the joint with 1 or 2 unknowns. So maximum 2 unknowns. Alright. So in this problem, you can see, so here we have FBA and here you have FBC. Alright. And here you have FBA and here you have FAC. Alright. And here you have FBC. So each member, they have their own force. Alright. Each member, they have their own force. Alright. So you can take any joint with maximum 2 unknowns. Alright. Here also you have AC. All right. So since you know already, since you know the value for each, this one you have AY is 500, and then you have that way you have AX 500, okay, and then you have CY 500, right? So take any join with two unknowns. So all join we have two unknowns, okay. You can take any join, right? For example, in this case, let's say we take join B lah, because they have already have one value here. You can take any join. Let's say you take join B. Take join B. Alright. So draw FBD for join B. Draw FBD for join B. So this is join B. Alright. So this is join B. Okay. So you have 500. Right. And then you have FBA. You can assume the direction of FBA, and then FBC. Okay, FBC. So the angle here are 45 degree. Yeah, 45 degree. Okay. So summation of Fx equals to 0. So you have 500 plus FBC sine 45 equals to 0. So FBC is basically minus 500 over sine 45. So you have 707 Newton, right? Minus. Okay, and then summation of Fy is equals to 0. So summation of Fy is equal to 0. You have minus FBA minus FBC cos 45 is equals to 0. So you have minus FBA minus with plus 707 cos 45 is equals to 0. So FBA okay, so FBA is equals to cos 45, right? 500. We have 500 Newton, right? Betul ke? Plus minus FBA is right. So this is positive. So this one is negative. So you draw again the correct configuration. Okay. So the true value or true figure is you have 500, and then FBC is minus, so that way lah. Alright, this is FBC. 707 Newton. Right, and FBA is plus, so this correct sign. Alright, you have FBA is 500 Newton. Alright, so FBC is push or pull to the joint. So this push. So when push, you have compression. So you state here compression C. FBA is pull from the joint or push to the joint. It's pull from the joint. So this is tension. Alright. So that means your figure or your truss is in tension lah. Tension means this way, right? It's tension, all going upward, right? So your FBA, so this one is in tension, all right? Okay. So with FB joint B. So repeat this step for the other joint, all right? So you have FBA done, you have FBC done, and then FAC, all right? FAC. The question asking for force in each member, all right? Force for each member. So you have done with FBA, FBC, and one more we have FAAC. FAC, this one. Okay, so this one is done. So we left with FAC. All right. So the force in AC, you can take any joint. You can take joint A or you can take joint C. Take the easiest joint. Alright. For me, I take for joint A because there's no angle. For joint C, you have 45-degree angle. So you can take joint A. Take the easiest joint you think you can solve. Okay, so for joint A, right? So draw FBD for joint A. Okay, so FBA are tension. So tension pull to the joint. So you have FBA. This one is FBA, which is how much? You have 500. Okay, and then you have AX. Here you have AX, also 500. And then you have AY, also 500. And then the unknowns are FAC. This one we don't know the direction, we just assume FAC. Tak tahulah. Alright. So you can congak lah jika bahasa Melayu kan. You can guess. So you have 500 here, you have 500 here. You have 500, so this one should be also 500 equilibrium. Right? So also 500 Newton. Okay. If this one to the left and this one must be to the right for the equilibrium, for the static. Okay, it's not moving, right? So 500 Newton going pull from the joint. So this one is also tension, right? So that's it. You done with FC. Okay. So you have FBA 500. You have FBC 707, and you have FAC 500 Newton. Okay. So that's it lah for the analysis of the joint. Okay. Ada soalan tak setakat ni? Any question? Alright, kalau tak ada question, kita move to the next slide or next example. Alright. So determine the force in each member of truss and indicate whether the member are in tension or compression. Right. Okay, this is problem number 2. Problem 2. Right. So step 1, find reaction at support. Reaction at support. Okay. So to find reaction at support, you have to do the FBD for the all lah. So let's say this one is pin. So you have BY and BX. I go fast lah, right? So this one you have, for this one is roller. So roller only have one A, AY. So this one is roller. This one is pin. Okay, AY. Okay, so find the reaction at support. So summation of moment at B is equals to 0. Why I take moment at B? Because they have two unknowns. Okay, so you have 400 times 2. This one is counterclockwise, is positive, and then minus AY times 2 is equals to 0. Alright, so AY is equals to 400 lah. Alright, so cancel, you left AY is equals to 400 Newton. Right, and then summation of Fx is equals to 0. Alright, so you have Bx. Ada lagi tak? Tak ada. So you don't have any other force except Bx equals to 0 lah. And summation of Fy is equals to 0. You have By plus Ay minus 400 is equals to 0. So By plus 400 minus 400 is equals to 0. Okay, so By also equals to 0. So this Ay is from here, right? So Bx 0, By is also 0. Bx is 0, By is also 0, right? Betul. Okay. So you left with Ay only. Ay you have 400 Newton. Alright. So find the reaction. Number 2. Select joint lah. Draw FBD at interested joint. Yang you pilih lah. Joint. Nak pilih joint yang mana? You can take joint at for you can take joint at A, B, C or D, it depends, but take the joint with less than max 2 unknowns. Alright, so here you have 1, 2, 3 unknowns. You cannot choose lah. So here we have 1 and 2. Okay, yang ni okay. This one you have 2 unknowns, and this one you have 3 unknowns. 1, 2, and 3. So you cannot take this joint. Yeah.
Doctor, can we take A?
Yeah, A also can. A, you can take A or C. All right.
Yes.
You can take A or C. You cannot take D or B because you have three.
3.
Yeah. Right.
Unknown.
Okay. Let's say you take join A lah. All right. You take join A. So let's say we take join A. All right. So join A, you have AY, which is 400, and you have FAB. FAB, and you have FAD. Direction you can guess. FAD. Right? With the angle of 45 degree. Right? So you can use your equation of equilibrium. So summation of Fx is equals to 0. So you have FAB minus FAD. Sorry, I take with Fy first, because Fy you have only one unknowns. You can take any. So Fy is equals to 0. So you have FAD sine 45 plus AY is equals to 0. So FAD sine 45 plus 400 is equals to 0. So you have FAD is equals to minus 400 divided by sine 45. So you have minus 565.6. 565.7. 0.69 or 0.7, right? Minus Newton, right? And then summation of Fx is equals to 0, right? So you have FAB minus FAD cos 45 is equals to 0, right? So you have FAB minus and minus 565.7 cos 45 to 0. So you have
400 je.
Yeah,
400.
400. Dah kira dah?
Dah kira. Negative 400. Tapi kalau saya nak check boleh je. Takut saya salah kira lah.
Cos 45. Yeah, 400. Plus or minus? Minus
Minus je minus.
Minus.
Alright. So the correct direction is this way lah. So this one is FAB. AB and FAD also minus, so this direction. Okay. FAD. Alright. So you need push to the joint, this means it's compression. Alright. This one also push to the joint, this is also compression. Tak perlu nak buat pula. Okay, compression lah. Okay. So we've done with dia nak setiap member tu. We've done with FAB and FAD. FAB is here. Here we done with this one, and then FAD, this one. All right, and then we continue with the other joint lah. All right. Let's say they take the joint C, yang ni pun sama. I think you can go through that for the other join. You can take join C, do the summation of Fy, do summation of Fx, and then you get the answer. FBC is 566. Okay, so push to the join, you have compression, right? FCD also push to the join, you got compression. All right, so do repeat the step for the each join. Okay, this is join C, join D. All right, so for join D also same, you have two unknowns, you can solve. FCD we got from previous steps, so you can take the equation or direction here. All right, so FAD, like this one, they get minus. All right, so the assumption is the other way around lah, this way. So you get push to the joint, which is compression. All right, so for FBD, they pull from the joint, you got tension. All right, so this is point D lah. And then you repeat step for the each joint. All right, this is joint A. All right, they'll do the joint A in the last. So you can choose any joint, but start with the joint with two unknowns. All right. Okay. So this is problem number 3. So far okay ke?
Okay sir, okay sir.
Yeah.
Okay, okay, Doctor.
Alright. So ini pun sama. Okay. So determine the force in each member for each member. Okay, each member indicates whether the member are in tension or compression. Alright. So first you need to find the reaction at support. So this is pin. Pin you have two, CY and CX. This is rocker. You have only AY. Alright. So find the reaction at support. You draw the FBD, and then you find the CX, CY, and AY. This one lah. CX, AY, and CY. Alright. You get the value of the reaction at support, and then now move to the next joint. So which joint we need to choose? Alright. So which joint you need to choose? Alright. So for joint A, you have two. You have here F A apa ni? FAD. Alright. You have FAD, and here also you have FAB. Okay. So for this joint, also you have two. Alright. This joint you have three. The upper joint. This also you have three unknowns. So you can take either joint A or joint C for your analysis. Okay. So this example, they take joint A lah. Okay. So when we do the joint A, you just put the value of AY. Okay. Summation of FY is equals to 0 here. So 600 minus 4/5 FAB. So this one you can assume first. You can assume direction. Okay. Equal to 0. And then summation of Fx, which is FAD. This one. Minus 3/5 70750 and equal to 0. So you need FAB lah. FAB. Alright. So you get the answer. FAB is 750, FAD is 540. So FAB push to the joint is compression. Alright. So FAD pull, tarik daripada joint, so you get tension. Alright. So repeat the step for other joint. let's say point D. Okay, point D, you have minus 450 plus FDB 600 equals to 0. Yang ni lah, minus 450 tambah dengan 3/5 FDB, dapat FDB minus 250. So minus means your assumption is the other way around, bukannya salah, cuma terbalik lah. So ke sana. Alright. So pull from the joint is tension. Alright. So determine.
Sir, why minus 450?
Sorry, why?
Sir, why minus minus 450?
Because it's going to the left. Sekejap. Okay, yang ni, this one, going to the left. So going to the left is minus lah. Okay.
Thank you.
Alright. So, alright. So you get the value 250. Alright. And then summation of Fy. Summation of Fy is equal to 0 minus FDC. Why minus? Sebab because it's going, the direction is
Down.
right. And then minus 4/5 equals to 0. You get the answer 200 Newton. Positive because our assumption is correct. Okay. Push to the joint is compression, right? And then do again for next point C. Do the same thing, right? This is easy because there's no angle. So FCB is 600, right? This one. Push to the joint is compression, right? So what actually happened is like this one. When push to the joint, for the bar is basically compression, right? Compression. Okay. Sebab apa dia, why is opposite here? Because it must be equilibrium lah. Okay. For the joint, for the bar, mestilah berlawanan arah. Itu basic principle lah. Alright. Tapi for the sake of analysis, when push to the joint is compression and pull from the joint is tension. This one also, right? Tension, compression. What actually happened? Okay, we do not analyze on the bar. Instead, we only analyze on the joint. So you can see what happened on the bar. Is it contention or compression? Okay, so this is the analysis joint. The analysis using joint, right? Joint method. Okay, so problem 4, I think you can try by yourself. We have answer here. Alright, you can go and try later lah. Alright. This one also you have 1, 2 unknowns, 1, 2 unknowns, 1, 2, 3 unknowns, 1, 2, 3 unknowns. So start with either point D or point B first, right? This one you can try by yourself. So this one is roller. So remember, for the roller, reaction are 90 degree to the floor. Okay, ada student yang tulis, there is some student would draw FBD this one like this. So ni salah lah, bukan. So the reaction 90 degree to the floor, like this one. Ini okay, alright. CY, okay. Mesti 90 degree to the floor, right? So ini you have A, Y dan A, X, okay. So here you have 1, 2, 1, 2, 3, 1, 2. So choose joint A or joint C for your analysis, right? Alright. So next subtopic is zero force member. Sometimes your trust is very complicated. So zero force member means that member has zero force. Okay. So zero force means the member not in tension or not in compression. So have zero force lah. So when zero force, you can remove the bar. Okay. If a joint has only two non-collinear member and there is no external load, then these two member are zero force member. Alright. Apa makna? What it means by two non-collinear? Collinear means straight line, right? You have bar and then you have bar here. So this is collinear. Let's say A, B, C. So A, B, C are collinear. If A, B, C are not collinear, that means it's not straight line. Okay? Or we can say it's not straight lah. Not straight for your understanding. For it's not straight line. If a joint has only two not straight line member and there is no external load, okay, so there is zero force member. For this example, DE, CD, AF, and AB are zero force member. Okay, we can see here ED are not 90 degree or not straight. Okay, and there is no external load, tak ada external load or support reaction, then this is a zero force member. So you can cancel this one, you can pangkal, you can buang yang ni. Alright, so ini pun sama, FA, FB tak ada external load. No external load means is no load lah, external load, so you can remove this one. Alright, so you left with like this. Okay, from all this complicated trust, you can simplify into this one. Alright, okay, so I repeat again lah. Alright, if you have two member, alright, two member not in straight line. And number two, no external force or support reaction. So itu adalah zero force member. So ini kita panggil sebagai zero force member. Okay. Contohnya inilah. Okay. We have two bar yang sengit macam ni. Okay. So tak ada no external force. External force mean you have let's say 500 ke, then you have support ke kat sini. Okay. So ni tak ada. So this one we call a zero force member. So you can simply cancel this member. Alright. So that is using two joint lah. Alright. For the zero force member. Okay. So definition number 2. If three members from a truss joint for which two of the members are collinear and there is no external load or reaction, then the third non-collinear member is a zero force member. Tak faham kan? Alright. So kalau kita ada 3 force member, if you have 3, let's say we have A, B, and then you have C, and you have D. Okay. AB and BC are collinear. Collinear means straight line. Collinear. Alright. Then CD are zero force member. Okay. Kalau lah AB dan BC ni straight line, member yang ketiga, the third member are zero force member. So you can simply cancel this one. Okay. Yang AB and BC you can cancel. Alright. Provided no external force. It's no external force lah. Let's say 500. So tak ada external force or no support reaction. Alright. So like this example, like this figure. So ED and DC are collinear. The third member, DA, are zero force member. So you can cancel this one. Alright. So DC and CB are collinear. So AC are zero force member. You can cancel this one. Alright. So you left with only like this. Alright. Okay. Clear, eh? We can see more example after this. Okay, so there are two conditions. One, before is you have when two member are not collinear, not straight line, then you boleh cancel lah semua tu. Kalau you have three force member, dua member straight line, two member straight line, and then third member you can remove. Alright. So using method of joints, determine all the zero force members of the rough truss. Assume all joints are pin connected. Okay, contohnya soalan ini, this question. Alright. Yang mana satu zero force member? Alright. You have yang ini GC zero force member. Alright.
DF.
Huh?
DF.
DF zero force member. And then you have when DF zero force member, you left with this one. So this one also zero force member.
Yeah.
Right. And then BH, is it zero force member? BH is not zero force member because you have external.
CH.
This one is external force. External force. So BH is not zero force member. It's okay. Alright.
CH.
PH also not zero force member because you have external force here. Alright. And then apa lagi? What else?
Sir,
Ya.
yang CG tu bukan dia ada external force kat ke?
Oh dia kira external force dekat joint. Yang ni kat luar ada lah. Oh sama sorry. Dia kira kat joint. Sekejap Sekejap. Dia kira dekat joint. Sekejap. Okay, joint mana? We look at which joint. Let's say we look at this joint. Okay. So this is zero force member lah. Alright. We look at this joint. This joint we cannot cancel BH because they have external force. But for the CH is zero force member. Alright. Because dekat H ni is no external force. Alright. And then we have FD, and also this is zero force member, and this is also zero force member. Alright. So you have GC. You have GC. GC is zero force member, and you have DF. DF is zero force member, and you have FC. FC is zero force member. Alright. BH is not zero force member. Alright, because you have external force here, 2 kilonewton. Alright, so you have 4 zero force member. Okay, so you can cancel that to simplify your question lah. Alright. CH ni zero force member ke? CH ni tak Alright. So you have the 3 lah. GC, DF and FC. Right. So you can prove lah using joint analysis. Alright. Okay. Like this one. Identify the zero force member in each truss. So which one is zero force member? Member yang tak ada force. You have BG is zero force member. Alright. Lagi tak?
Sir. Oh, sir.
Ya. Yeah.
Boleh zoom sikit sir?
Boleh apa?
Zoom sikit. Tak clear sangat. Okay.
Boleh?
Okay.
Okay. So identify the zero force member in each truss. So you left with GB lah. Alright. GB is zero.
GC and FC.
Yang mana? Which one?
FC and JC.
Yeah. GC, right? GC and
FC.
FC is also zero force member. Alright. FD, is it zero force member, FD?
No.
Yeah, FD also zero force member. So you left with this force lah. You left with this one. So it's easier for you to analysis. Alright. Okay. Ini for this truss, determine the number of zero force member. You have 1, 2, 3, right? So you have 3 zero force member, right? Ada soalan tak? Ini tak apalah, ini you can. Okay. I think that's all for today. The method of section, I think I will continue on next Thursday, right? Method of section, right? So for the method of joint, any question?
Thank you, Doctor.
Okay. No. So I think you can take your attendance at ULearn, right? Take your attendance ULearn. So this Thursday I will continue with the method of section, alright? Method of section. Okay.
Thank you, Doctor.
Okay, thank you. See you on Thursday. Okay, so don't forget to take the attendance, and I will take the link here. Okay, thank you. See you on.
Thank you. Assalam.
Thank you, sir.
Thank you, Doctor.